In the 7th video, we are going to be solving quadratic equations by factoring. That means that we will be using the Zero Factor Theorem. Now, the Zero Factor Theorem tells you exactly what you need to do. The first word, 0, means you need to have it set equal to 0. So in this first equation, you see that it's already set equal to 0. The second letter, f, for factor, means you need to factor completely. So in this polynomial, it's a trinomial, so we expect to factor this as two binomial factors. And this is equal to 0. Now when we factor this guy, we've done a lot of factoring so far, so we know this guy is going to be x plus 3 times x plus 4. Now according to the Zero Factor Theorem, if you multiply to equal 0, that means that one of these guys must be 0. So to multiply to equal 0, x plus 3 is equal to 0, or x plus 4 is equal to 0. So we separate this, and we just solve each of these equations. So to get x by itself, we just subtract 3, so x equals negative 3, or here x equals negative 4. Now we get two solutions, and we expect to get two solutions because you see that the degree of this polynomial is 2. So we expect to have two solutions. And now let's look at number 2. Number 2 has x squared plus 9x equals 10, and again, Zero Factor Theorem. Z means it needs to be equal to 0. It's not right now, so we can easily remedy this by subtracting the 10 over to the left side. Then we need to factor completely. So this trinomial will factor as x plus 10 times x minus 1. And when we set each factor equal to 0, we could separate it and do just what we did on this first one, x plus 3 equals 0 and so on. But the more of these you do, the more you see that it's actually pretty simple. If I have this guy right here, x plus 10 is equal to 0, well, that's going to be true when x is equal to negative 10. Or look at this other guy. X minus 1 is equal to 0. Well, that happens when x is equal to positive 1. Just add 1 to both sides. You got the answer. So we expected to have two solutions because we had a degree of 2. Now in this third problem, again, we are using the Zero Factor Theorem. The first step is to get it equal to 0, and this guy is equal to 0. The second step says to factor. And as you look on the left side of this, it's already factored. And so T means use the theorem. Set each factor equal to 0 and solve. Now you could do that here. So that means that 3x minus 5 is equal to 0. But we should have solved enough linear equations for us to be able to come up with the answer very quickly. Well, what are the steps that you would do to get x by itself? Well, first you would add 5 to both sides, and then you would divide by 3. So there's your solution. And you can do something very similar over here in this one. How do you get x by itself? You would have to subtract 15 first. So looking at this guy, you would have to move the 15 over, and then you would divide by 7. So very quickly, you can get the answers here. Now this was easy for us because the problem was set up already being equal to 0 and being factored. Well, let's see some problems we're going to take a little bit more work. Number 4, 8x squared minus 10x minus 7 is equal to 0. So this guy's already equal to 0. We just need to factor this. So it's a trinomial. We expect it to factor as two binomial factors. When I look at the factors for 8, I can use 1 and 8, or 2 and 4. Now 2 and 4 have a common factor of 2. Since 2 goes into 10 evenly, then I'm going to use those numbers to factor. 7 is prime, so I just need to pay attention to where I put that. One place is ridiculous, and that's right here. Because if I put the 7 here, 7 times 4 is 28. I'm going to be very far away from 10. But when I put the 7 here, I'd get a 14 and 4. So 14 and 4 can give you 10 as long as this is a minus 14 and a plus 4. So you see you get your 8x squared, you get your negative 7, and inside and outside would check to give you the negative 10x. Now, solve this like we did in number 3. How do you get x by itself? You'd have to subtract 1 and divide by 2. Or, the other factor would yield the solution, add 7, divide by 4. So once we get the factorization, solving the rest of it is not a problem. Now look at number 5. Number 5 can be kind of tricky if we're not paying attention. See, a lot of students will see this guy as being factored, but it doesn't equal 0, so it doesn't count. You have to have it equal to 0 first, then you factor, then you use the theorem. So the easy way to do that here in number 5 is to FOIL, multiply this out. When you do that, you get x squared minus 3x plus 2x minus 6 is equal to 50. And now that I have this, I can get it equal to 0 by moving the 50 over. Just subtract 50 on both sides. And while we do that, let's go ahead and combine like terms. So that's x squared minus x minus 54 is equal to 0. And now it's just like all the other equations we've done so far in this homework. We just need to factor this. And this guy is going to factor as well, this guy doesn't really factor for us, does it? I think I did something wrong. Well, I have no problems making mistakes. I see a mistake right now. How did I get 54? And why'd you guys not stop me? Well, that's supposed to be a 56. And so now this guy factors as x minus 8 times x plus 7. See, sometimes when you're doing problems, you ever come to the situation, you go, something just doesn't look right, it's not really what I'm expecting. This homework says to solve by factoring, but I had something here at 54 that it could factor, but I would never be able to get the 1 here in the middle. So that let me know that something was wrong. And I guess I just got going a little bit too fast. But take your time, go back, check your work, find your mistake. So here I find out that x is equal to 8, or x is equal to negative 7. So we can plug this in and check it very quickly. If I plug in 8, you see that 8 plus 2 is 10, 8 minus 3 is 5, 10 times 5 is 50. And if I were to check negative 7, you're going to see something very similar to that. You'd have negative 5 times negative 10. Now, number 6. Number 6 is not set equal to 0, so we can take care of that just by moving everything over to the left side. When you move terms, you want to make sure that your polynomial will be in descending order. It always works out better for you that way. Now when I move everything to the left, I see that I have something that doesn't have a common factor other than 1, but I do have 4 terms. And 4 terms indicates that I should factor by grouping. In this first group, I have a common factor of x squared. If I factor that out, I'm going to have x plus 2. In the second group, my common factor is a negative 9. When I factor that, I end up with an x plus 2. Make sure you watch your signs here. So now the x plus 2 is the factor that was common, and it was being multiplied times both the x squared and the minus 9. Now, when you see the f in ZFT, that means to factor completely. So x squared minus 9 can go a little bit further. And x squared minus 9 is the difference of 2 squares, and that's x plus 3 times x minus 3. So I've got 3 factors. It seems like I'm going to have 3 solutions. And I knew that because my highest exponent there was a 3. So my 3 solutions will be x equals negative 2, or x equals -3, or x equals +3. So we get 3 solutions from this equation. The degree of 3 indicated that we should have 3 solutions. That doesn't mean we'll have 3 different ones, but we're going to have 3 solutions. Sometimes solutions are repeated, and that's something we'll talk about in a later video.